How would you find the antiderivative of 1 divided by x square root x squared plus x plus 2? So the first thing that you should notice is that there's a quadratic under the square root. So the proper substitution whenever you have a quadratic with all plus signs would be u minus x squared, right? Setting that equal to the quantity inside, which is x squared plus x plus 2. Okay, and then solving for x is a little bit difficult, but you should do that because you need the dx, right? So u squared minus 2ux plus x squared is equal to x squared plus x plus 2, right? The x squared are gone, right? And then you add 2x on both sides, right? 2ux plus 2ux, and then subtract 2 on both sides, right? Because you want to isolate the x, right? So I'm gonna just switch the sides. So I'm gonna do x minus 2ux is equal to, so I'm just switching the sides, right? 2ux minus 2, so x minus plus 2ux, yeah, that should be plus 2ux, the minus 2 is gone. Let me see, so this side becomes this side, and then here we have u squared, this is gone, right? So minus 2. So as a result, x can be factored out. 1 plus 2u is equal to u squared minus 2. So x, dividing both sides by 1 plus 2u, gives us u squared minus 2 divided by 1 plus 2u. Okay? So that's the x. Now the dx we needed for the top, so we found this, but we need the top. So dx is going to be what? So let's underline that because we're going to need it. So the dx, so the dx, we need the product quotient rule for this, right? So first differentiate the top, 2u, and then the bottom is untouched, minus, now the top remains intact, u squared minus 2, and then this is differentiated, which gives you just 2 divided by this thing squared, the denominator squared, right? Right, so that's that. And this simplifies to what? To 2u squared plus 2u plus 4 divided by 2u plus 1 squared, right? I'm just switching the 1 plus 2u is the same thing, right? Because the addition is commutative. Okay, so that's the dx. Let's underline that. We're going to need it. Now we must make sure that we don't forget the du for the dx, right? So there was a du and there was a du. Right, so now what is the integral that we're going to have so far? The dx is found here. So 2u squared plus 2u plus 4 over 2u plus 1 squared, right? And let's leave the du until the end because we're going to have it anyway. So that's the dx. What is going to be the x? The x is this, but the x is in the denominator, right? So we have to flip this fraction so that this winds up on the top, right? So 1 plus 2u divided by u squared minus 2. And then one more thing. What is going to be the square root of this in terms of u? Notice that we had the proper substitution u minus x squared as this without the square root. So the square root both sides would give us u minus x without the square, right? Just u minus x. So u minus, but don't forget the x is not in terms of u. We need to have it in terms of u. And we have it here already, right? So u squared minus 2 over 1 plus 2u. So simplifying this will give us 2u squared minus u squared is just u squared, right? Using the LCD. LCD is 1 plus 2u, right? So plus u plus 2 minuses plus 2 divided by the LCD 1 plus 2u. Excellent. So, and again, since it's in the denominator, we will have to flip. We'll have to flip this, right? So 1 plus 2u divided by u squared plus u plus 2, right? And now we can add the du because we're ready, right? Let's separate this work because this was used for substitutions, and now we're going to work with the integral itself in terms of u. It might seem crazy, but you'll see that it's actually going to yield us a very good result. So now notice that we can simplify this. There are two factors of 1 plus 2u and exactly two factors in the denominator, right? So that's cancelled out. Also, we can factor out the 2, right? So let's factor out the 2 for this polynomial. So u squared plus u plus 2, right? Factoring out the 2 in each term, over u squared plus u plus 2 times 1 over u squared minus 2, right? This part here, du. And notice again, I went one at a time, but actually now you can factor this out too. So this is a beautiful result. So we get this 2 integral 1 u squared minus 2 du. This calls for partial fraction decomposition, right? And this is going to be, let's work it out here, a over u plus radical 2 plus b divided by u minus radical 2. And I've factored this out, absolutely, right? Factoring out would give us two factors. This times that gives you precisely this, right? So now multiplying both sides of this by this denominator gives us 1, right? This denominator is gone as a result. A multiplies this part because this part cancels out if you multiply this whole fraction numerator denominator by this. I'm sorry, not the numerator denominator, just the numerator. Just the numerator multiplied by this. This is gone, but this one remains. Right? So u minus radical 2 plus b. Similarly, this one's gone. This one multiplies the b. U plus radical 2. So now comparing the coefficients, x to the 0th power first, the constant, right? 1 on the left side, negative radical 2a, right, the constant, plus radical 2b, radical 2b. Now x to the first power, oh, I'm sorry, not the x, we were dealing with the u. I'm so used to having the x variable, right? This is the u variable, all right. So we have u variable, now u to the first power. So let me see, there's no u to the first power, so 0 on the left side. On the right side we have a, right, plus b, plus b. So now adding twice equation 2 to 1, so we have to multiply this by 2, right? If you add twice the equation second to the first, you will eliminate the a, right? It will be I'm sorry, radical 2, not twice, but radical 2 times the second equation, right? If you add the radical 2 times the second equation to the first equation, you will eliminate the a, right? Because it will be negative radical 2a plus radical 2a, right? So the only thing that will remain is the b value that you need to solve for. Okay, so if you do that, you will get what? You will get 1 still, because the 0 times radical 2 is still 0. This one goes away, right? Just like I said, 0, but this one remains. So radical 2 plus radical 2, 2 radical 2b. So that means b is equal to what? Simplifying this, 1 over 2 radical 2 1 over 2 radical 2 can be also expressed as radical 2 over 4, right? So radical 2 over 4 is the b value. A value is what? Has to be the negative of this, right? So as to yield a 0, right? Using this equation. So negative radical 2 over 4, right? So that's the a value. So as a result, what is the integral? The integral is, so instead of this, we'll have this, and we found the a and b, right? So negative radical, my bad, radical 2 over 4 over u plus radical 2 plus the b value, radical 2 over 4 over u minus radical 2, right? du. Already looking better. So let's simplify. So this 1/4 goes outside, it becomes 1/2. So negative radical 2 over 2 as a result, right? Notice if you use the substitution one more time for the bottom, if you use v is equal to denominator, dv is going to be 1, right? So that doesn't change. But you know that 1 over v will be ln, right? So we have to have ln, absolute value of u plus radical 2. And absolute value always used for the ln, right? Because the inputs can never be 0 or negative. Okay, and the same thing here. Now there's a positive, right? I'm going to do it here. Plus, same thing, same simplification, right? Radical 2 over 2. Right, so radical 2 over 2 ln again. Absolute value of u minus radical 2, absolute value close. So now, and don't forget there's a constant, so plus a constant because it's the antiderivative. Let's start with this one first and bring everything back in terms of x, right? So radical 2 over 2 ln of, what is the u value in terms of x? So the u value in terms of x is gonna be what? Keep in mind that u minus x was square root of this whole thing, right? So u is gonna be this part here plus x, right? Because I'm just gonna write it here. So u minus x was equal to the square root of this, x squared plus x plus 2, right? So the u, adding x on both sides, will give us plus x. U is this plus x, right? So let's have that. So that's x squared plus x plus 2 plus x outside the radical, right? Gives us the u value. Don't forget minus radical 2, absolute value closed. Now this part, minus radical 2 over 2, same thing, ln x squared plus x plus 2 plus x again, but this time plus radical 2, right? Plus radical 2. And of course plus a constant. And now you can simplify this. I mean, not simplify it, but put it in a rather single form, in a single expression form, right? So you can take the radical 2 over 2 out, then combine everything into one ln expression, basically take the ln of the quotient, and I'm going to show you how. So square root x squared plus x plus 2 plus x minus radical 2 over this part, square root of x squared plus x plus 2 plus x plus radical 2, absolute value closed, plus a constant, right? Because the ln property states that if you take the ln of the quotient, it will yield you the ln of the top numerator minus the ln of the bottom. That's exactly what the previous statements said, right? So this is the correct answer, and I hope this video was useful to you. Thanks for watching, and I'll see you in my next video.